Greetings and welcome to the channel dedicated to drowsy science. We're going to go into the fascinating realm of weather tonight. Every day we are surrounded by the never-ending dance of storm and sky. Despite its apparent simplicity, the sky above us is teeming with wonder and chaos. It is a living ocean of air that is agitated by unseen rivers of heat, rippled by winds, and painted with clouds. Sunlight scatters into colors within this delicate structure. When lightning splits the sky with fire, storms that can span entire oceans are created. The weather is the planet's breath, heartbeat, and song in addition to its mood. Please like and subscribe if you like these light science adventures, or leave a comment below with one of your favorite facts. It also makes it easier for others to find their way here. One drowsy person at a time. You only need to rest for the time being, though. Take a seat, take a deep breath, and let your thoughts stray into the intriguing realm of weather. Let's get started. The weight of one storm cloud is more than that of 1,000,000 elephants. A floating cloud appears to be weightless and soft when viewed from above, resembling cotton being pushed across the sky. However, the reality is astounding. Hundreds of thousands of tons of water can be contained in a normal cumulus cloud, the type that floats on a warm afternoon. Even though each drop is too tiny to be seen alone, they combine to form an unfathomable mass that is heavier than 1,000,000 elephants standing side by side. However, because the water is dispersed into innumerable tiny drops, each of which is carried upward by warm air, the cloud remains suspended and floats. One of the major contradictions of weather is the appearance of something so huge and massive, yet fragile and ethereal. Remember that a cloud bears the weight of entire lakes in its tender embrace the next time you crane your head to watch it drift languidly over you. The temperature of lightning is higher than that of the sun. A sharp lightning strike splits the sky in an instant. Although it appears to be pure white fire, its actual temperature is considerably more shocking. A lightning strike is several times hotter than the sun's surface, with temperatures reaching over 30,000 degrees. The amount of energy involved is astounding. It is strong enough to superheat the surrounding air, converting it to plasma and causing the sky to light up with dazzling brightness. When thunder rolls across the landscape, we hear the abrupt expansion of air. Every lightning strike compresses unfathomable heat and energy into a split second, making it akin to nature's own laboratory experiment. Some bulbs create a dazzling chain that connects the sky and the ground, extending for miles. Lightning is both life-giving and violent. In order to nourish the very plants that keep us alive, it aids in fixing nitrogen into the soil. Thunder is the sound of air exploding due to sudden heat. Sometimes sharp and shocking, other times like distant drums, thunder sweeps low and deep over the sky. The voice of lightning is actually what we are hearing. The air is heated so rapidly and powerfully during a lightning strike that the molecules are unable to keep up. A shockwave that travels faster than sound is produced when they violently rush into expansion. Thunder is that shockwave. The sound may crack, rumble, or echo between buildings and hills, depending on how far away you are. The distance of the storm can be determined by calculating the seconds between lightning and thunder, because light travels significantly quicker than sound, and we observe the flash long before the noise reaches us. Thunder serves as a reminder of the tremendous powers at work above us, encased in the storm's rolling cadence, and it is both a wonder and a danger. Raindrops are not shaped like teardrops. Raindrops that are rounded at the bottom and pointed at the top frequently appear in children's drawings as flawless teardrops. Raindrops, however, are not at all like that in reality. Surface tension holds the tiniest drops together, making them nearly perfectly spherical. Air resistance flattens their bottoms as they get bigger, making them resemble hamburger buns rather than teardrops. They disintegrate into smaller droplets if they are too large, and lose their ability to hold together. When you picture each drop falling from the sky in its own ideal shape, This small detail makes rain even more lovely. The way falling water appears on windows or cheeks, stretched by gravity as it glides downhill, creates the appearance of teardrops. Raindrops, however, carry their own hidden geometry, little spherical diamonds, as they glide down into fields, roofs, and rivers. Not the jagged forms we envision. Ancient oils and cosmic particles give forth the scent of rain. The earthy, reassuring scent that emerges after a downpour has a name: petroor. A combination of exceptional ingredients creates this fragrance. Long periods without rain cause little plants to discharge oils into the dry soil. These oils are released into the atmosphere when rainfall hits the ground and bursts soil bubbles. Simultaneously, the air is filled with the rich earthy scent of geosmin, another substance made by bacteria that live in the soil. Additionally, lightning can separate oxygen and nitrogen molecules during storms, producing ozone, which gives the mixture a harsh new sound. The end result is the distinct fragrance of rain, which is connected to live microorganisms, old soils, and even the chemistry of the sky itself. You're breathing in a tale as old as the earth and as vast as the atmosphere when you inhale that scent. The speed at which snowflakes fall might vary greatly. We imagine snow floating soundlessly, with each speck spinning slowly. Furthermore, some snowflakes fall shockingly quickly, while others actually drift gently. Their size and structure determine their speed. Tiny, fragile crystals may descend at a minuscule fraction of a meter per second, appearing to be reluctant to land. At velocities nearer a few meters per second, larger flakes composed of several crystals adhered to one another can fall. Flakes are thrown in spirals, upward and sideways by wind currents, which further complicate matters. Flakes can travel for miles before they touch down in certain situations. Therefore, as you watch snow fall, you are witnessing a ballet that is orchestrated by gravity, air resistance, and the secret structure of ice. Each descent is different, a silent trek through the stratosphere before descending into the wintry silence. Coins are narrower than certain snowflakes. The majority of snowflakes are tiny, fragile crystals that are hardly larger than a fingernail, but they have the potential to develop to amazing sizes in the correct circumstances. Flakes can adhere to one another to form clusters as large as a dinner plate or wider than a coin when the air is moist, the winds are light, and the temperature is just right. In Montana in the late 1800s, the largest snowflakes ever recorded were reported to be over 15 inches across. Think of the huge flakes falling gently from the sky like frozen feathers. Winter storms are made more magical by the knowledge that the sky may create huge flakes, even though most of us will only ever see flakes the size of pennies or less. The intricate architecture of ice crystals produced in quiet high above the ground is contained within every flake, regardless of size. You may be unable to see your own hand in a blizzard. A snowstorm is more than just a lot of snow. Snow and wind combine to create a blinding wall during a storm. Visibility can decrease to a few feet during one. Sometimes travelers who find themselves in such circumstances report not being able to see their own hands extended in front of them. Strong gusts whip the snow into the air, causing a spinning whiteout in which all sense of direction is lost. Wind chills and temperature drops can quickly cause exposed flesh to freeze. Blizzards rank among the most hazardous weather phenomena for people who live on broad plains or high mountains, capable of confusing even seasoned adventurers. However, a weird beauty can also be seen inside the severity of the storm. The conversion of the world into a white, blank canvas where chaos and silence coexist. Like onions, hailstones can form flawless layers. Raindrops are transported high into the cooler cloud levels by a powerful updraft from the thunderstorm, where they solidify into small ice pellets. After that, these pellets can drop back down, collect more water, and rise once more, freezing layer after layer. Hailstones may carry dozens of concentric rings by the time they descend to Earth. Similar to an onion's layers or a tree's growth rings, Their buried past is exposed when they are cut open. Every layer documents a trip through the storm. Larger hailstones can dent cars, destroy crops, and shatter windows, but smaller ones might not cause any harm. The largest is capable of weighing over a pound. Nevertheless, they are organic sculptures sculpted by the raging breath of clouds, and their icy pattern carries the storm's memory. A volleyball-sized hailstone was the biggest hailstone ever observed. An incredible piece of hail dropped from the sky in the little South Dakota hamlet of Vivian in July 2010. It weighed about 2 pounds and was about the size of a volleyball, measuring 8 inches across. Imagine a ball of ice like that, speeding toward the earth. Luckily, it fell into a field instead of hitting a house or a person, but it is still the biggest hailstone ever measured in the US. Other massive hailstones have been produced by storms all across the world. Each was created by strong updrafts that stacked ice on top of ice as they moved up and down inside storm clouds. The majority of hailstones are barely bigger than peas, yet records like Vivian's serve as a reminder of the extremes of nature. Rarely, turbulence in the sky can create terrifyingly large ice missiles that are subsequently launched back to Earth. Straw can be thrown through solid timber by tornado gusts, with winds so powerful that they can transform the commonplace into the unimaginable. Tornadoes are one of nature's most amazing phenomena. It also happens to be one of the more peculiar aspects of tornado lore. In a tornado, lightweight straw can be pushed right through thick wood. Debris is accelerated by the winds to such remarkable rates that even the softest items turn into sharp bullets. Straw fragments have been discovered lodged in utility poles, fence posts, and even storm-damaged home walls. It serves as a reminder of the ferocity with which the air may spiral into a vortex. Heavy weaponry is not necessary for the tornado. It is able to transform grass into arrows. To be in the path of such a storm would be to confront a force that subverts the laws of ordinary existence, turning delicate objects into destructive tools. The speed of a jet airliner is comparable to the fastest tornado winds. Hurricanes or strong storms at sea may come to mind when we think of strong winds. However, even those are left behind by tornadoes. On the enhanced Fujita scale, the strongest tornadoes, known as EF5s, have winds of over 300 mph, which is equivalent to a passenger jet's cruise speed. Cars can be flung like toys into the air under such gusts. Whole buildings may disappear from their foundations, and steel beams may become twisted or warped. The noise of these winds, according to storm chasers who have survived close encounters, is like a freight train bearing down, huge and unstoppable. Although tornadoes of this magnitude are fortunately uncommon, their existence alone evokes wonder. They serve as a reminder that the air around us can occasionally travel at unfathomable speeds and are the planet's most concentrated outbursts of atmospheric rage. Hurricanes emit more energy than all of Earth's power plants put together. A hurricane is a storm of an almost unfathomable magnitude. Fueled by warm ocean waters, it travels hundreds of kilometers, accumulating heat and moisture to become a massive spinning engine. A fully developed cyclone releases more energy in a single day than all of humanity's power plants put together. Imagine a single grid receiving power from every coal plant, nuclear reactor, wind turbine, and solar panel, and still not being able to match the output of a single storm. The majority of this energy is released as heat that is transported away by billions of condensing raindrops, with the remainder being released as roaring waves and strong winds. Standing close to the edge of a hurricane allows one to experience even the smallest hint of its strength. However, satellites in orbit can only depict its whirling vastness. It is the most amazing weather machine on the planet. A hurricane's violent center is its most dangerous area. You will witness something nearly unreal when you enter a hurricane's eye. There is a startling silence following hours of roaring winds and pouring rain. The clouds disperse, the air clears, and occasionally the sun even comes out. This is the eye, a round, frequently 20–40 meter broad area at the center of the storm. Although the water surface is stable and the winds are quiet here, it is not a safe spot. The eye wall, a tall ring of thunderstorms where the storm's winds reach their maximum intensity, encircles the eye. The eye is like a spinning wheel's motionless heart, calm only because everything around it is raging so violently. The eye is haunting, serene, lovely, and full of fear for those who have seen it, for they know that the storm will return with full force after a short respite. In a single season, monsoons have the power to completely alter landscapes. Life is synchronized with the monsoon rhythm in many regions of the world. These are seasonal winds that change course and carry heavy rains. Parched areas may remain cracked and dry for months as they wait for help. Then the heavens open virtually overnight. Fields flood, rivers rise, and forests bloom with green. The monsoon rains can be both beneficial and harmful. Hundreds of millions of people are fed by the crops they water. However, they can also cause landslides and floods that alter the terrain. In regions of Africa, Southeast Asia, and India, entire cultures and histories have developed in tandem with the monsoon cycle. Farmers follow the seasons when they plant and harvest. Its arrival is celebrated with festivals. Observing a monsoon is a way to determine whether, on a continental scale, the atmosphere is changing so drastically that it alters the landscape of countries. Decades may pass with no rain in the Atacama Desert. In addition to the Atacama, there are arid regions. Extending throughout Chile's north, it is regarded as Earth's driest non-polar desert. Parts of the Atacama may experience decades without detectable precipitation, and some weather stations have never recorded a single drop of rain. NASA has examined the soil as a Mars analogy because it is so arid. However, life manages to find a way here. While microscopic organisms cling to existence deep under the ground, certain plants extract water from fog that drifts in from the coast. The desert comes alive with color when it does rain, which is not often. Known as the Desierto Fido, wildflowers blossom on the beaches. To stand in the Atacama is to experience the quiet of a location that has hardly been affected by the elements, where the sky is wide and each drop of water is a wonder. Rain barriers cover the wettest spot on the planet. The village of Mausanram, located in northeastern India, is frequently referred to as the planet's least habitable location. Moist air is forced higher every year by monsoon winds that funnel into the nearby highlands from the Bay of Bengal. The outcome is astounding, an annual rainfall of around 12 meters on average. Imagine so much rain that the sound of water is a constant companion. Rivers rush down streets and waterfalls swell from cliffs. Villagers even construct live root bridges to span the flooded waterways, and roofs are made of durable materials to endure the flood. Rain completely shapes life here. In Mausanram, precipitation is measured in tall walls of water that return each year, even though most people estimate it in inches or centimeters. It serves as a reminder that the weather is not uniform. In some locations, the rain never stops, while in others, it never starts. Car tires could be melted by the highest temperature ever recorded. The desert floor in Death Valley, California, was swept by a furnace-like wind in July of 1913. 56 was the official recorded temperature. The highest temperature ever consistently recorded on Earth was 57 degrees Celsius, or 134 degrees Celsius. Metal sears to the touch, asphalt softens, and car tires run the risk of melting if driven for an extended period of time in such heat. The body finds it difficult to release heat, and without water, survival becomes challenging even in the shade. Such extremes, where daytime heat surges off the rocks in shimmering waves, are what gave Death Valley its name. Death Valley is still the best, but other locations like Iran and Kuwait have been close. The existence of such temperatures on our own planet serves as a sobering reminder of the strength of the atmosphere. Above us, the air is more than just soft and pleasant. It can turn into a deadly raging furnace. Metal may be frozen in a matter of seconds by the coldest air on the planet. There is a point in the middle of Antarctica, on a high plateau far from the sea, where the air itself seems strange. Scientists measured the temperature here at Vostok Station in 1983, and it was 89. Colder than dry ice, 2 degrees Celsius is cold enough to break glass and cause steel to become brittle. Satellites have recently detected much lower values, nearer 98 degrees, in neighboring hollows. Under those circumstances, exposed flesh can almost immediately freeze solid, machinery locks up, and breath turns into crystals. This is cooler than Mars's typical surface. Living here calls for extreme preparation, including insulated suits, heated shelters, and ongoing attention to detail. Nevertheless, weather still moves. Winds howl, snow piles, and clouds move lazily overhead, even in this freezing core of the planet. Where Earth's atmosphere meets its most extreme quiet, it is the coldest frontier. More people are killed by heat waves than by any other kind of extreme weather. Because of their dramatic and obvious force, storms and floods frequently make headlines. The heat wave, on the other hand, is the deadliest type of weather. The human body struggles when the air becomes stagnant and the temperature remains uncomfortable for days or weeks. Heat stress increases in the absence of respite, straining hearts and drying out tissues. Where concrete and asphalt absorb heat, forming islands of oppressive air, cities suffer the most. Buildings release the heat they have stored during the day, so there is little restlessness at night. Tens of thousands of deaths have been caused by heat waves worldwide, which frequently go unnoticed and impact the elderly, the very young, and those without access to shelter. It may not be as visible as a hurricane, but its violence is evident in the thousands of fish that perish in hot rivers, the fields of wilted crops, and the mounting hospital admissions. The most pernicious threat from the weather is heat waves, which can strike silently but with catastrophic force. You may be unable to see your own feet due to dense fog. One of the weather's most subtle tricks is fog. Pale quiet enveloped the earth as a cloud descended to the earth. Typically, it causes the horizon to disappear, turning trees and buildings into ethereal shapes. However, in rare instances, fog can get so thick that it only covers a few feet, making it difficult for individuals to see their own feet clearly. Sound also acts oddly in this type of fog, appearing muffled and near, as if the air were thick. Drivers are compelled to move forward with unsettling caution, ships slow to a crawl, and airplanes are grounded. Even if it is gentle, fog can be one of the most hazardous weather conditions. Nevertheless, passing through it can have an unearthly quality, akin to entering a dream where the boundaries of reality have vanished, leaving behind nothing but whiteness and the sound of your own breathing. In deserts, dew can hold enough water to support life. Rain is frequently scarce amid the arid stillness of deserts, but it is a silent savior. The ground rapidly cools as the sun goes down. Additionally, moisture condenses onto rocks, plants, and even the tiniest sand grains if the air temperature falls below a particular threshold. The desert awakens every morning, studded with tiny water beads. This dew can mean the difference between life and death for plants and animals that have adapted to live here. In order to catch droplets that glide into their mouths, beetles angle their bodies. Dew is sent toward thirsty roots by some plants' stems. Using nets or surfaces made to catch these glistening water gems, even humans have mastered the art of harvesting it. Even while each drop is tiny, together as a whole, they offer nourishment in areas where rain may not fall for months. Dew is desert rain that falls in whispers rather than in torrents. Spiky forests of ice can form from frost crystals. Frost can occasionally create lovely designs on windows on winter mornings, such as curling leaves, fern-like tendrils, and sparkling lace. When water vapor freezes straight onto a cold surface, ice crystals like these are created. However, under the correct circumstances, frost can develop into something far more exotic and expansive. Hoarfrost, or spiky forests of ice can occur on Arctic plateaus and mountain peaks due to frost. Here, the crystals are like glass sculptures that catch the early light as they extend upward into ragged towers that are occasionally inches long. Layer by layer, vapor condenses onto the surface of each spike, growing it until the entire landscape is covered in frozen blades. They remain crisp, crystalline, and delicate in the quiet of chilly air. They collapse at the touch if you get too close. However, for as long as they persist, they elevate the everyday world to a supernatural realm. A forest of ice formed from cold breath and frigid air. Cities face a perilous glassy shell when ice storms hit. An ice storm can be beautiful, but it's a dangerously beautiful type of beauty. Raindrops become extremely cold liquid when they fall through a layer of frozen air near the ground. They are still liquid while they descend, but as soon as they come into contact with the surface, they are ready to freeze. Roads turn into invisible ice sheets. Crystal sculptures are created from tree branches, and the sudden weight causes electrical cables to sag. At night, headlights create glistening reflections of the frozen environment. Every blade of grass and twig was covered with glass, but danger lurks beneath this genius. Roads are rendered impracticable. Trees break. Additionally, entire communities can experience days without power. Every surface is slippery and dangerous when you walk outside during an ice storm, creating a delicate world of frozen diamonds. It is the most treacherous, beautiful, and dangerous weather. Skyscrapers are not as tall as dust devils. The earth may heat unevenly on a hot, dry afternoon, causing warm air columns to spiral upward. A dust devil can occasionally form when this air starts to spin. Some rise to incredible heights, twisting towers of dust taller than buildings, while many are tiny, swirling only a few feet across. Dust devils, as opposed to tornadoes, dance across fields, deserts, and even parking lots when they form under clear skies. The largest can lift roofs, topple fences, or scatter debris on the ground, while harmless ones can only fling leaves and sand. From the air, pilots have described seeing enormous dust devils that loom above the ground like transient giants. They are short, tumultuous, captivating little tornadoes that show how alive the air is even on seemingly quiet days. Watching one is like witnessing the sudden, dramatic appearance of unseen air and heat currents. Waterspouts have the ability to whirl like liquid tornadoes across the ocean. Picture yourself standing on a beach and watching a thin, winding column climb from the ocean to the clouds above. This is a waterspout, which is a tornado-shaped air and mist vortex that forms above water. Some are rather feeble, whirling innocuously across lakes or bays before disappearing. Some are strong enough to break masts, toss boats, and send waves into a frenzy. Stories of waterspouts looming over the horizon like spectral funnels have long been told by fishermen. They can be oddly lovely from a distance, spirals of silver mist illuminated by lightning or sunshine drifting across the ocean. At close range, however, they are chaotic forces that combine ocean spray and storm gusts. Waterspouts serve as a reminder that the wrath of a tornado is not limited to the land. Even the serene expanse of the ocean can abruptly transform into a swirling water tower that reaches for the heavens. Planes can be smashed out of the sky by microbursts. One of the most hazardous and obscure weather hazards is microbursts. They happen when a thunderstorm abruptly releases a large volume of chilly air that quickly spreads outward and plunges toward the ground. A microburst may appear to people on the ground as an abrupt, strong gust of wind that flattens fields or topples trees. However, the risk is far higher for aircraft. When an aircraft enters a microburst, it may abruptly lose lift and descend more quickly than the pilot can respond. The majority of thunderstorms are brief, localized occurrences that last less than an hour. Supercells, however, are distinct. With revolving updrafts, these enormous, well-organized storms can persist for several hours. They can cover hundreds of miles in satellite imagery, sometimes enlarging whole US states. Entire weather systems come to life within their soaring clouds, which can reach heights of over 10 meters. Thousands of lightning flashes every minute. Layers of hailstones are developing. Gimmery tornadoes spinning into being. Although they are uncommon, supercells are the catalysts for the planet's most catastrophic weather. Observing one shape from afar is like watching the atmosphere exercise its muscles. The horizon itself is reshaped by a massive, dark, rolling wall of clouds. These storms appear to be living, breathing, spinning, and expanding until the ground underneath them seems insignificant. Some thunderstorms have a duration of over 12 hours. Thunderstorms are frequently thought of as brief events that consist of a flash of lightning, a downpour, and then clear skies. However, thunderstorms can persist for much longer in the appropriate circumstances. Mesoscale convective complexes are systems that can move across large regions and remain intense for up to 12 hours. They contain waves of storms that feed on warm, humid air and release torrential rains as they rise and fall in a self-sustaining cycle. These long-lived thunderstorms have the potential to produce strong gusts, lightning strikes, and extensive floods. They resemble live things when viewed from above, appearing as vast masses of cloud that are illuminated by flashing lightning. The storm becomes a nighttime companion for people below them. Repeated flashes, never-ending rumbles, and seemingly eternal rain. They serve as a reminder that bad weather isn't always temporary. The sky itself can occasionally settle in for a protracted and tense stay. Over the mouth of the Catumbó River in Venezuela, a storm has been generating lightning for centuries. For generations, a storm has been brewing. This natural phenomenon, called Catumbó lightning, is characterized by lightning storms that happen nearly every night for more than 200 nights a year, often lasting 10 hours at a time. The region's distinct topography, which combines chilly Andean air with warm Caribbean winds, makes storms a regular occurrence. The shimmering light in the sky over Lake Maracaibo is seen from miles away. Even sailors far out at sea could watch the silent fireworks display. It has been referred to for generations as the Maracaibo Lighthouse, a beacon that is always visible. Why this place is so unusually stormy is still being investigated by scientists. However, one thing is for sure. Lightning pulses with such unrelenting, timeless rhythm nowhere else on Earth. Mount Everest is not the highest altitude that weather balloons can reach. Around the world, hundreds of weather balloons are launched into the skies each day, carrying instruments known as radiosondes. They appear to be straightforward balloons filled with hydrogen or helium. They do, however, reach remarkable heights. They ascend at a rate of roughly 1,000 feet per minute and float into the stratosphere itself, well above clouds and airplanes. They might reach a height of more than 20 meters by the time they explode, which would be far higher than Mount Everest. The horizon curls against the blackness of space at those altitudes, and the air is so thin and cold that temperatures drop to 90 degrees C. These balloons measure wind, humidity, pressure, and temperature as they climb, returning data that helps us predict the next few days' weather. They are explorers of the atmosphere, but most of us cannot see them. Maps of the unseen ocean of air surrounding our planet are made by silent travelers. Hurricanes may be seen in real time by satellites from space. The satellites, which orbit hundreds of miles above the planet, act as silent protectors above us. Satellites record the spiral arms of storms as they form over the waters, spanning hundreds of miles, their eyes open like giant pupils, gazing skyward. A hurricane is stunningly attractive from space, a cloud-swirling geometry that never stops spinning. However, there is destructive power hidden beneath those elegant patterns. These storms can be tracked in real time by modern satellites, which can map rainfall, measure wind speeds, and even look inside using infrared sensors to observe cloud heat signatures. This ongoing attention to detail saves lives and gives coastal cities valuable hours or days to get ready. Storms used to come much more suddenly before satellites. However, We can now observe how they develop, move, and ultimately disappear back into the ocean. Satellites view Earth's most powerful storms as captivating, alive patterns rather than chaotic phenomena from the icy silence of space. Raindrops in the air can be tracked by Doppler radar. Radar enables the familiar green and red patterns on weather maps as a storm approaches. However, contemporary Doppler radar is much more than just a rain detector. It can determine the position, speed, and direction of raindrops and snowflakes by reflecting radio waves off of them. This enables meteorologists to observe storms in incredible detail, identifying bands of heavy rain that could cause floods or tracking rotation that could produce tornadoes. Doppler radar essentially creates a visual picture of the atmosphere's undetectable movements, a colorized representation of whirling chaos. Numerous droplets tumbling through the sky are represented by each red, green, or purple pixel. Doppler images are like storm fingerprints for those who can read them. They show their underlying structure and allow us to see the weather's choreography as it plays out above us. One type of space weather is the northern lights. Shimmering curtains of crimson, purple, and green dance across the night sky far over the Arctic regions. These are the aurora borealis, also known as the northern lights. Additionally, they have a cosmic origin even if they appear to be earthly weather. The Earth's magnetic field collides with streams of charged particles from the Sun, which are then directed downward toward the poles. They excite atoms in the upper atmosphere and make them glow when they hit them. The atmosphere itself is coming to life as what we perceive as shifting ribbons of light. This serves as a reminder that our atmosphere acts as a barrier against the Sun's never-ending flow of energy. And it's not just Earth weather. Seeing the aurora is like seeing the magnetic pulse of the Earth, a clear connection between solar storms and the thin layer of gases that shields our planet. It is a work of cosmic poetry that is illuminated by the sky. Earth's weather systems can be affected by solar storms. Clouds of plasma and magnetic energy shoot across space at incredible speeds during a solar storm eruption. These storms have the ability to disrupt Earth's magnetic field and produce dazzling auroras in a few days. However, they can also penetrate farther, interfering with power systems, satellites, and even atmospheric circulation. Strong solar storms, according to some scientists, might momentarily affect Earth's weather by changing how the atmosphere absorbs energy. Although these relationships are nuanced and poorly understood, they serve as a reminder that the weather on Earth is not isolated from space. The Sun's invisible hand is always stirring our environment, and we dwell inside its extended reach. Solar storms can have an impact on our surroundings, even when the skies are clear. The weather on Earth is never completely its own in this way. It is a component of a broader dialogue with the star that keeps us going. Local cloud cover can even be altered by jet contrails. On a clear day, you might be able to see the long, thin trails that airplanes have left all across the sky. When exhaust and chilly, humid air mix, these contrails can remain and spread, eventually combining to produce thin cirrus clouds. Contrails, despite their seeming fragility, have the power to modify local weather by altering the way heat and sunlight pass through the atmosphere. Widespread air travel has been demonstrated to significantly enhance cloud cover in some areas, slightly warming nights and cooling days. Scientists noticed odd variations in day and nighttime temperatures following the September 11th attacks in 2001, when flights were briefly banned in the United States. This gave them an idea of how much contrails typically affect the equilibrium. It serves as a reminder that even tiny traces of human activity can have a profound impact on the weather, changing the planet's breath and painting the sky in ways we rarely notice. Boulders the size of vehicles can be moved by flash floods. Typically, water is gentle, eroding mountains grain by grain and sculpting valleys over millennia. Water, however, reveals its opposite side during a flash flood: unexpected, enraged, and unstoppable. A brief period of intense rain can cause dry gullies to turn into roaring torrents and rivers to swell in a matter of minutes. Sand, branches, and even tons of stones are carried by these water barriers. It is possible to lift and sweep away entire cars. Overnight, bridges collapse, streets become rivers, and landscapes are reshaped. Flash floods are particularly deadly because they can happen suddenly and can occur just upstream under seemingly calm skies. The force of flowing water leaves a lasting impression on those who are in its path. It is the voice of gravity amplified by storm, reminding us that even the most delicate element, water, can become one of the most destructive powers on Earth due to weather. There have been droughts that have persisted for hundreds of years. The world slowly but significantly changes after the rains stop. Soils crumble, waterways dwindle, and crops wither. In the past, some droughts have lasted for millennia, but most only last for a few months or years. Tree rings, lake beds, and even the remains of extinct civilizations bear the scars of these massive droughts. Evidence from North America indicates that during the Middle Ages, the western United States had droughts that lasted hundreds of years, much longer than anything that is currently observed. Entire regions are altered by these droughts, turning grasslands into deserts and forests into grasslands. People are compelled to relocate, leave their homes, or undergo unusual adaptations. Drought is a silent meteorological phenomenon. No thunder, no storms, no spectacle. Just an endless emptiness that stretches till histories and geographies slant beneath it. In a subtle sense, a drought can have just as much force as a flood or storm. El Niño has the ability to change the weather on every continent. El Niño is a phenomenon that causes the Pacific Ocean to warm every few years, and the atmosphere reacts when it does. Weather patterns spread over the world when winds and currents fluctuate. While portions of Asia suffer from drought, South America experiences heavy rains. El Niño's pulse can change North American hurricanes, monsoons, and even winter storms. A shift in ocean temperature close to the equator can have far-reaching effects that are felt thousands of miles away. It is among the most lucid examples of the interdependence of Earth's systems. Every continent's weather is influenced by the rhythmic movement of the water and atmosphere. El Niño is a mystery and a challenge to scientists, farmers, and fishers. A reminder that the enormous ocean currents beneath the sky, rather than a single location, determine the planet's climate. In cooling winds, La Niña has the opposite effect. La Niña, the opposite of El Niño, frequently follows. The Pacific Ocean's surface cools, and the winds that blow across it get stronger at these times. Though inverted, the impacts are as widespread. Where there was once rain, there may now be drought. New areas may experience hurricane formation. Additionally, winters become more severe in various regions of the world. La Niña is a component of a natural cycle that reverberates across the entire atmosphere, a swinging pendulum of heat and cold in the tropical Pacific. These changes, however imperceptible to the naked eye, have the capacity to change storm patterns across North America, rainfall in Africa, and typhoons in Asia. It is a glimpse of the planet's profound connectivity to consider that the cooling of ocean waters in one region can influence weather thousands of miles elsewhere. A planet where the weather is genuinely a single, enormous system. Ocean currents function as enormous heat rivers. Currents that are so large and constant that they mimic secret rivers flow beneath the ocean's surface. These currents, in contrast to freshwater rivers, are influenced by the Earth's rotation, temperature, and winds. They balance the climate by spreading the sun's energy and moving massive amounts of heat throughout the world. While colder water sinks and glides back toward the tropics, warmer water from the equator moves toward the poles. With its hot equatorial zones and frigid mid-latitudes, a large portion of Earth would be uninhabitable without these invisible rivers. Rather, currents moderate extremes by acting as Earth's covert thermostat. From a distance, the whirling G's they create appear to be ocean-spanning spirals of living art. It is like touching the edge of a system that connects continents. an unending flow that connects all weather when you stand on a shore and feel a warm stream sweeping past your feet. During the winter, the Gulf Stream keeps Europe warm. Even though Europe is located on the same latitude as Canada, its winters are considerably milder. The course traverses the Gulf Stream, which is the Atlantic Ocean. Warm water from the Gulf of Mexico is carried northeastward by this strong current, which releases heat into the atmosphere along the way. By the time it gets to Europe, the cold of winter is lessened because the air above it is warmer than it would be otherwise. Much of northern Europe would experience weather more akin to Siberia, with harsher winters and shorter growing seasons, if the Gulf Stream didn't exist. This constant flow of warmth shapes entire cultures, cities and farmers. Because changes in the Gulf Stream could have significant effects on a global scale, scientists are still keeping a careful eye on it. But for the time being, it continues to be one of the most vital lifelines on Earth, a heat-transmitting mechanism and an unnoticed collaborator in the weather-climate dance. Arctic cold may be forced southward by the polar vortex. The polar vortex is a mass of cold air that spins far above the North Pole. Usually, powerful winds keep this cold circulation locked high in the atmosphere. However, it occasionally wanes and sways, leaking Arctic cold southward. When this occurs, areas that are far from the poles, such as the Midwest of the United States or Central Europe, end up in the grip of extreme cold, with temperatures dropping to dangerously low levels. These epidemics have the power to smash records, cripple cities, and freeze rivers. Although the occurrence is not new, the term polar vortex has become commonplace in news headlines. It is a component of the Earth's atmosphere's inherent rhythm, a reminder that the Arctic is a part of all of us and is not isolated. You might feel the edge of that enormous spinning crown of ice the next time frigid air suddenly rushes across your city. Around the world, a volcanic explosion can alter the weather. The effects of a powerful volcano eruption extend well beyond the actual mountain. Ash and gases are blasted by explosive eruptions up into the stratosphere, where winds disperse them all over the world. Sulfur dioxide atoms can remain for months or even years, reflecting sunlight and causing the Earth to cool. The Northern Hemisphere experienced frost and starvation in 1815 as a result of Mount Tambора's eruption, which came to be known as the year without a summer. Rivers froze in midsummer, crops failed, and ash clouded the skies. More recently, for a number of years, the 1991 eruption of Mount Pinatubo reduced world temperatures. A clear reminder of how interconnected Earth's systems are is provided by volcanic eruptions. The wrath of a mountain can change the global equilibrium of air and sunlight. Even the Earth's fire, which whispers via storms and clouds, has a voice in weather. Lightning can be produced by forest fires. Flames can reach hundreds of feet into the air when a forest burns with extreme heat. Ash and smoke are raised into the air by strong updrafts caused by the heat. Similar to a thunderstorm, particles inside these clouds smash and produce static electricity. Pyrocumulus clouds, which are storm clouds formed by fire and have the ability to shoot lightning bolts back down onto the flaming forest, are the end outcome. A vicious cycle of flames feeding on one another could result from these lightning strikes starting fresh fires. Firefighters occasionally see lightning flashing in the sky while flames rage below. A spooky confluence of storm and flames. This occurrence demonstrates that weather is a force that both shapes and is shaped by landscapes. A forest on fire turns into a severe weather system that is ablaze with fire and thunder. A powerful reminder of the remarkable ways in which nature can magnify itself. Fire smoke can create odd new clouds. Large-scale wildfires do more than just darken the horizon when they send smoke plumes high into the sky. Clouds can form when water vapor condenses around the small particles in smoke, which can serve as nuclei. These clouds can occasionally get so dense that they create broad shadows over the ground, changing the temperature below. In severe situations, smoke-driven clouds ascend thousands of miles into the stratosphere, Far from the original fire, they may remain there for weeks, gradually changing the weather patterns. The sight consists of eerie clouds with odd colors that shine red in the sun and are colored orange or gray. During midday, pilots have reported flying through hazy, smoky skies that resemble dusk. These clouds originate from the Earth's own fires, not from the sea or the sky. Evidence of the interdependence of fire and weather, both of which have the power to create and influence one another in surprising ways. The Amazon is reached by dust from the Sahara Desert. Winds send millions of tons of fine dust into the atmosphere each year from the Sahara Desert. These dust clouds, which may occasionally be seen as golden veils spanning thousands of miles in satellite imagery, traverse the Atlantic Ocean. A large portion of this dust eventually settles on the Amazon rainforest, where it enriches the soil with vital nutrients, especially phosphorus. Parts of the Amazon would find it difficult to maintain its amazing biodiversity without this transoceanic voyage. It serves as a potent reminder of the interconnectivity of the globe when one of the driest locations on Earth provides food for one of the wettest and most lush. In an invisible interchange, even the air serves as a conveyor belt connecting the jungle and the desert. You might be breathing in the fine dust of ancient dunes that have been transported across seas to support life in another hemisphere when you breathe in air that has been touched by far-off places. Hurricanes have the ability to stir the sea till plankton light illuminates it. Hurricanes are well known for their damaging rain and winds, but they also create another beauty beneath the waves. Plankton, which are microscopic organisms that occasionally glow when disturbed, are stirred by the enormous storm as it churns the water. During storms, sailors have reported sailing over seas that were shimmering ghostly blue, with the surface appearing to be alive. As a defense mechanism brought on by turbulence, the plankton's internal chemical reactions produce this bioluminescence. Even though it is not visible from satellites, the location leaves a lasting impression on people who see it. A hurricane is painting the sea with light below, in addition to raging above. We are reminded by these luminous waters that weather affects all strata of the Earth. Even in the midst of devastation, storms can produce moments of surreal beauty as life itself reacts with flashes of living fire to the ferocity of wind and waves. Mountains are carved into valleys by the weather. Despite their seeming permanence, mountains are constantly being reshaped by the weather. Rock is broken apart by rain seeping into crevices and freezing and melting them. Sand grains are carried away by wind, which scours cliffs that are exposed. Rivers carve deep valleys and canyons when they cut into the mountains. Even the strongest peaks erode over millions of years, their sharp edges softer, their summits dropped. The weather persistently fights the Himalayas and Rockies, which are still rising from geological pressures. Every rockfall, rushing stream and landslide contributes to the atmosphere's silent chiseling. Earth would be a harsher, sharper planet if weather didn't erode it. Rather, the rolling hills, lush valleys, and meandering rivers are shaped by the weather. We are aware that you are witnessing the art of weather carved into stone throughout the ages as you stand in a canyon or look at the weathered face of a mountain. Stone can be shaped by wind into spires and arches. Strange shapes emerge from the earth in deserts all around the world. Arches, spires, and almost alien-looking rocks that resemble mushrooms. These are the wind sculptures. Over millennia, the wind erodes delicate layers of rock while leaving behind harder ones, carrying sand like a natural sandblaster. Certain formations resemble tall pillars. Others frame the sky with beautiful arches. This unrelenting effort produced the stone arches of Utah, the wind-sculpted pinnacles of the Sahara, and the Monument Valley in the United States. Even while the wind might feel soft on your skin, it has the power to gradually sculpt landscapes that appear to have been created by an artist. Walking among these formations is like strolling through a gallery of natural sculptures, each sculpted by unseen air currents that move grain by grain over stone rather than by chisels. Sand can become glass when struck by lightning. The tremendous heat of lightning can turn quartz grains into glass when it strikes sandy soil. The impact solidifies the sand into hollow branching formations known as fulgurites, which resemble solidified frozen lightning. These delicate tubes, whose surfaces are glossy and wavy from molten minerals, can extend several feet underground. Each one is a signature of fire engraved into the ground, a record of a single lightning strike. For geologists and collectors, fulgurites are unique gems. Every item is a naturally occurring sculpture that was created in a moment of intense energy. It's like having a lightning fossil in your hands, evidence of the sky's ability to change stone in an instant. The next time you witness a lightning strike, consider that it might be creating crystalline tunnels beneath the ground as a memory of the storm's fleeting but remarkable impact on the planet. Glaciers reshape continents by moving like rivers of ice. Glaciers appear to be frozen rivers that stretch through valleys without any movement. However, they are always in motion and can flow anywhere from a few centimeters to several meters every day. Their unrelenting, sluggish action sculpts landscapes on a massive scale over centuries. They polish rock into smooth plains, drag boulders for miles, and grind mountains into U-shaped valleys. Glaciers covered a large portion of North America and Europe during the last ice age, advancing and retreating to reshape entire continents. Their remains can still be found today in high mountain ranges, Greenland and Antarctica, where they continue to shape the landscape. The weight of time itself is felt when one is close by, a river of solid ice instead of water, using careful strength while moving. Glaciers are dynamic environments, whispering of old winters and the force of weather frozen into motion. It is slow, unstoppable, and transformative. On a freeway, avalanches can travel faster than automobiles. There is frequently a precarious equilibrium between slope and snow in high alpine regions. An avalanche may start when such equilibrium is upset. What begins as a little slide swiftly picks up speed, accumulating snow, ice, and debris into a thunderous torrent. Roads, buildings, and woods can be swept away by avalanches, which can reach speeds of nearly 80 mph, faster than cars on a freeway. Once it starts, the sound is unstoppable, like thunder rolling down a mountainside. Avalanches can be caused by weather, weight, or even a single footstep, making them a continual threat to skiers and climbers. However, they also contribute to the natural cycle of the mountains by feeding valleys below, redistributing snow, and sculpting slopes. Observing one from a safe distance is an opportunity to experience nature's unexpected wrath, a reminder that snow is not always kind but can quickly turn into a raging river of devastation. Underwater, icebergs conceal over 90% of their mass. A startling reality is the source of the expression, tip of the iceberg. Only a small portion of what is underneath the surface is visible to us. The majority of an iceberg's size is concealed beneath the waves as it floats in the ocean after breaking off from glaciers or ice shelves. Just 10% of it is visible. The remainder is hidden beneath the surface, huge and unseen. As the Titanic tragedy has shown, icebergs are deadly for ships because of their hidden mass. While some icebergs are little, others are enormous, towering over skyscrapers and extending for miles. They quietly change ocean currents and ecosystems by releasing fresh water into the ocean as they float. It captivates the imagination to think that something that vast might float softly, largely invisible. Only the deep waters that cradle them can truly appreciate the enormity of icebergs, which are monuments of frozen time that slowly melt into the ocean. Ancient living forms are locked up in permafrost. Permafrost, or earth that has stayed frozen for thousands of years, is found in the frozen soils of Siberia and the Arctic. It contains microorganisms, seeds, and even the remains of long-extinct creatures like mammoths. These fragments remain preserved, locked away in Earth's freezer, as long as the permafrost remains frozen. Ancient secrets come to light when it thaws. Tens of thousands of years-old seeds and even bacteria that had lain dormant for millennia have been brought back to life by scientists. Carbon dioxide and methane, which have an impact on the climate, are also released when permafrost is thawed. Touching permafrost, a layer of soil that connects the frozen past and the living present, is like touching time itself. There can be echoes of past worlds beneath your feet in addition to ice and dirt. Keep your eyes off them until the weather and warm air decide to let them out again. Rivers that thunder beneath the ice can be formed by glacial meltwater. Despite their quiet and solid appearance, glaciers are teeming with secret rivers. Melted water oozes into crevices and tunnels when the sun warms their surfaces, descending far into the ice. There, like underground thunder, it congregates into thundering streams that sculpt passageways beneath the glaciers. These rivers have the capacity to become strong enough to raise the glacier itself a little bit off the ground, which will facilitate its movement. Yolops, also known as glacial outburst floods, occur when meltwater unexpectedly breaks from below, filling valleys. Standing atop a living, breathing system where water and ice are continuously conversing is what it means to walk on a glacier without realizing the torrents rushing just below. These hidden rivers serve as a reminder that glaciers are dynamic landscapes that are alive with the pulse of weather and water moving beneath the frozen surface rather than being inert blocks. Animals migrate across continents based on the weather. Animals travel with the weather everywhere in the world. Birds seek out the sun's warmth. Changeable seas are followed by whales. As the seasons change, caribou also traverse tundras. The weather serves as the invisible compass that directs these migrations, which are among the most amazing natural phenomena. Rainfall patterns determine where herds can graze, ocean currents guide schools of fish, and winds transport monarch butterflies thousands of miles. These enormous motions can be shifted by even little weather variations, changing long-standing routes. Observing a migration means determining whether it has resulted in mobility. Rain, wind, and storms are all part of life's basic instincts. Numerous species would get lost, and there would be no big migrations on Earth without the cycles of the weather. Every journey, where the guides lead the tourists on land, at sea, and in the air, is a poignant tale etched in the air itself. Monarch butterflies travel thousands of miles in response to weather conditions. Millions of monarch butterflies journey up to 3,000 kilometers each autumn from Canada and the northern United States to forests in central Mexico, beginning one of the longest migrations in the insect world. With the help of the sun, magnetic field, and weather, their delicate wings enable them to fly over plains, mountains, and even the Gulf of Mexico. When conditions are too severe, they wait out storms and ride tailwinds to conserve energy. This cycle is completed by successive generations of kings, who carry on the trip left by their forefathers, who never came back. Their success is determined by the weather they encounter. A population can be destroyed by a powerful storm, but they can also be accelerated by favorable winds. The ability of such fragile organisms to traverse a continent while being challenged and carried by the weather serves as a stunning reminder of how all life is interconnected by the atmosphere in which we live. Birds travel along unseen warm air rivers. Birds frequently soar without beating their wings, circling elegantly as if suspended in invisible currents high above fields and woodlands. When the sun heats the earth unevenly, it creates rising columns of warm air, which are known as thermal currents. They are used by birds, particularly large ones like vultures, hawks, and storks, to move quickly over great distances. They can glide for hours by locating one thermal after another, which saves energy during lengthy migrations. Their circling patterns appear calm and sluggish from the ground. In actuality, however, they are negotiating an unseen weather map. These same thermals are also used by glider pilots who soar silently alongside birds. Thermals serve as a reminder that the atmosphere is a living landscape of rising and falling air rather than a blank expanse. These invisible rivers turn into skyways for those who can detect them, whether they are human or feathered. Rainfall serves as the guide for locust swarms. Because of their capacity to completely destroy landscapes in a matter of hours, locust swarms have been dreaded for centuries. Miles of these insect armies, sometimes numbering in the billions, can darken the sky as they move by. The weather has a significant role in what causes them. After rainstorms turn deserts into verdant pastures, locusts flourish. When food is plentiful, their numbers soar and they enter swarming mode. They are then transported across continents by winds and storms, sometimes covering hundreds of kilometers in a single day. Swarms of locusts are described in ancient chronicles as divine punishments. However, we now understand that they are the children of the weather, created out of cycles of rain and drought. To be in the path of a swarm is to see the influence of the atmosphere manifested in innumerable wings. Despite the modest size of each insect, when combined and directed by the weather, they produce one of nature's most powerful forces. Overheated oceans cause coral reefs to bleach. One of the planet's most dynamic ecosystems is the coral reef. Numerous fish, invertebrate and plant species can be found there. However, they are also brittle. Corals coexist with microscopic algae known as zooxanthellae, which give them color and nourishment. A condition known as bleaching occurs when ocean waters become too warm, causing the corals to expel these algae in distress and appear ghostly white. Corals can suffer without their algae partners, leaving behind dead skeletons where once thriving reefs previously flourished. Reefs throughout the tropics are in danger due to an increase in bleaching occurrences in recent decades. Satellites can even observe these enormous pale spots extending across seas from space. However, when things get better, corals can bounce back, sometimes even after years of dormancy. It's like watching a living rainbow turn to bone as you watch a reef bleach. It serves as a reminder of the close relationship between climate and weather, and the well-being of even the tiniest marine life. Whole civilizations have been destroyed by changes in the weather. Weather has subtly influenced history since its inception, despite the fact that it is frequently recounted as a tale of monarchs and conflicts. Rivers that supported cities have dried up due to protracted droughts. Farmland has been engulfed by floods, and civilizations have been starved by changes in the monsoon. According to archaeological evidence, abrupt climate changes caused the collapse of entire civilizations, ranging from the magnificent cities of the Indus Valley to the Akkadian Empire in Mesopotamia. People were forced to leave homes they had built over generations ago. Trade routes faded, and crops perished. Not all weather-related disasters are caused by fire or storms. At times, it gradually tears society apart like a strand torn from a tapestry. We frequently notice the effects of climate change when we gaze upon deserted cities or destroyed temples. Human ambition is only one aspect of the birth and fall of civilizations. Other aspects include skies that gave or withheld, shifting winds, and rains that never materialized. The Mayan Empire might have been overthrown by a single drought. The ancient Maya constructed towering buildings, studied the skies, and etched their records into stone deep within the Central American jungles. However, many of their magnificent cities had been abandoned by the 9th century. One of the best indicators of the cause of this collapse, which has been discussed for years, comes from the weather. Evidence of a protracted drought that lasted for decades and saw a substantial decline in rainfall in the area can be found in sediment cores and cave development. Without water, populations declined, conflicts increased, and crops failed. As the bush engulfed the ball courts and the powerful pyramids, they fell silent. Although the Maya people themselves lived, their empire disintegrated and underwent permanent alteration. It is sobering to consider that such a strong society may be overthrown by changes in the weather, unseen winds, and no rainfall. It serves as a reminder that even the greatest cities rely on the sky, and that human history is inextricably linked to climate. Storms determined the outcome of ancient battles. Weather has frequently determined the outcome of conflicts rather than just strategy. After attempting to invade England in 1588, the Spanish Armada was dispersed and destroyed by strong storms in the North Atlantic. When Kublai Khan attempted to attack Japan centuries ago, typhoons wrecked his fleets. The Japanese referred to these storms as kamikaze, or divine winds. Mud, rain, and snow have halted armies and changed the course of campaigns even in more modern times. In World War II, the D-Day landings were only successful because meteorologists discovered a brief window of good weather, but Napoleon's retreat from Russia was disastrous due to the harsh winter cold. Although storms are impartial, they have influenced history and determined the destiny of our nations. Sometimes the most potent commander in the midst of combat is the sky above. Rivers in the center of Europe were frozen during the Little Ice Age. The Little Ice Age was a time on Earth that lasted from the 14th century until the 19th century. Winters became harder and longer. Crops suffered in the cold as glaciers moved forward. In Europe, the London River's tempests frequently froze solid, becoming so thick that whole festivals could be held on its icy surface. Frost fairs with tents, marketplaces, and even ice skating on the frozen river are shown in historical paintings. Canals in the Netherlands frequently froze, yet ice skating was ingrained in the local way of life. The era was frigid enough to have an impact on history, art, and cuisine, even if it wasn't a true ice age. This centuries-long cold was caused by a combination of changing ocean currents, volcanic eruptions, and variations in solar activity. Imagine large rivers frozen into solid ice streets to get a sense of how even slight alterations in the environment affect people's daily lives. Heat islands produced by cities are warmer than those found in rural areas. On a summer afternoon, you could feel as if you've entered a hotter universe as you walk from a shaded park into a downtown call. Scientists refer to these areas as urban heat islands, because cities are better at absorbing and retaining heat than natural environments. Steel, concrete, and asphalt absorb solar radiation during the day and release it gradually at night, maintaining temperatures that are several degrees higher than those in the nearby rural areas. Air conditioners release heated air, skyscrapers block airflow, and car pollution exacerbates the effect. Particularly at night when cooling relief is never provided, these heat islands might increase the danger of heat waves. There are solutions. It helps to create green places, paint rooftops white, and plant trees. Nevertheless, the phenomenon demonstrates how local weather is altered by human design. The city itself becomes a climate, a man-made hotspot that shines against the surrounding, colder countryside. Local winds can be accelerated and bent by skyscrapers. You may notice that the wind picks up speed while you're at the base of a big tower. The way towering buildings channel air is what causes this effect. Wind is pushed downward and around the building as it encounters a steel and glass wall, producing gusts that are much stronger than in open spaces. These gusts are strong enough in some cities to topple bicycles, toss umbrellas, and make it hard to walk. They continue to be a powerful illustration of how human constructions interact with weather, even if architects today create buildings with open parts or curved shapes to lessen these urban gales. The air can swirl with unexpected violence at street level, yet from the top of a skyscraper, the winds may be calm and constant. The skyline serves as more than simply a background. It bends the air's unseen flow into new patterns, changing the atmosphere itself. Burning sunsets can be caused by air pollution. Even though sunsets are always lovely, occasionally they shine with an almost unbelievable intensity. Across the horizon are purple streaks, deep crimsons, and fiery oranges. Tiny particles in the atmosphere may be the cause of this sight. Only the deeper reds and oranges reach our eyes because shorter light wavelengths are scattered by dust, smoke, or pollution. Around the world, Sunsets following large volcanic eruptions have been characterized as flaming and otherworldly, with ash floating high in the stratosphere. Pollution shows how minor changes in the atmosphere may modify the sky's canvas, even though it is bad for your health. Every sunset is a product of the interaction of sunshine and air, molded by the invisible particles floating above us. The hidden fingerprints of weather and environment are also visible when you observe a scarlet horizon, in addition to the sun's radiance. Rain can be created by seeding clouds with particles. Humans have attempted to persuade clouds to stop raining in areas that are in dire need of water. Particles such as dry ice or silver iodide are released into the sky during a procedure known as cloud seeding. In order to assist droplets in getting big enough to fall as rain, these particles serve as nuclei around which water vapor condenses. Since the middle of the 20th century, attempts at cloud seeding have been made with varying degrees of success, occasionally increasing rainfall by a small percentage. Weather becomes a field experiment as the particles are released by airplanes, rockets, or even ground-based sources. Cloud seeding has been utilized in the United States, China, and the United Arab Emirates, but it is not a panacea. The notion that people might influence clouds to produce rain serves as a stark reminder of how we influence the weather. It is the alchemy of the atmosphere itself, used by science when it's needed. The weather for the following day is frequently predicted by red skies in the evening. Sailors love the red sky at night. Sailors take caution when the sky is red in the morning. There is actual atmospheric science behind this proverb. The presence of dry, dusty air to the west, where weather systems usually approach, is often indicated by a red sky around sunset. This points to steady conditions and promising weather in the future. However, a red sky at dawn can mean that the same dry air has already moved on, leaving unstable weather in its wake. A visible indicator of the atmosphere's condition, the crimson hues of the sky are created by sunlight, scattering through particles and moisture. Long before satellites and predictions, shepherds, farmers, and mariners used these signs to help them navigate their days. The rhyme conveys wisdom that has been tried and tested over centuries, despite its imperfections. Dawn and dusk are not just beautiful hues. They are divine messages, light-painted prophecies from long ago. A circle is a rainbow. Typically, we can only see half of it from the ground. Although they look like elegant arcs across the sky, rainbows are actually complete circles of light. Because the horizon obscures the other half, we often only see the upper half. But when pilots look down on storms from above, they occasionally report witnessing full circular rainbows. Sunlight penetrates raindrops, bends, reflects off the inside surface, and then bends once again as it exits to form each rainbow. This bending creates a circle of brilliance by dividing light into its spectrum of hues. The sun's angle determines the circle's size, yet it is always there in its entirety. A secret dimension of amazement is added when we recognize that the rainbow we see is only a partial peak. Above us, what appears to be an arc is actually a full wheel of color, raindrops falling in a beautiful circle of light. Lights and hidden roots are revealed by double rainbows. A rainbow can occasionally emerge with a fainter twin above it if certain conditions are satisfied. When sunlight bounces off raindrops twice rather than once, a double rainbow is produced. The outer arc is created by the second reflection, which returns light at a different angle. The colors are inverted in this secondary rainbow. The exterior is violet and the interior is red. Because less light enters Alexander's band, the area between the two rainbows, it frequently seems darker. Although double rainbows are common, they always have a mystical quality and fill the sky with dual arcs of color. For generations, poets and artists have praised them, and scientists view them as graceful examples of optics in action. When two rainbows emerge, the splendor of the storm's afterglow is doubled, and each rainbow is already a wonder. It's as if the sky is exposing hidden levels of its brilliance. On cold days, sundogs shine like extra suns. Strange companions may show up next to the sun on really cold days when ice crystals are floating high in the sky. These are sundogs, which are luminous patches that gleam like phantom stars on either side of the sun. They are created when sunlight splits into rainbow-like colors as it passes through hexagonal ice crystals in cirrus clouds. Sometimes they burn brightly, giving the appearance of three suns gleaming in the sky, while other times they shine dimly, like halos. When the sun is low on the horizon, which is typically at sunrise or sunset in the winter, sundogs are most visible. They were seen by ancient peoples as omens, symbols of strength or mystery in the sky. For us, these are brilliant examples of the interaction between the chilly breath of the atmosphere and everyday light. The secret elegance of sunshine painted on frigid skies is revealed when one sees a sundog. When sunlight bends through crystal clouds, halos form. On a cold day, you could notice a ring of light surrounding the moon or the sun when you look up. When light travels through innumerable tiny ice crystals suspended in tall, thin clouds, a halo is created. The light is bent by the crystals at exact angles, encircling the brightest object in the sky with a brilliant circle. Since the cirrus clouds that produce halos are the first indications of shifting conditions, they frequently indicate the arrival of a weather front. Along their margins, they may display subtle rainbow hues or shimmer in pure white. Particularly ethereal are the moon halos that glow at night, which are delicate rings that float against the night. These straightforward forms are the result of many crystals that are softly drifting, and all of them bend light in the same way. A halo is a piece of sky-born geometry as well as a forecast, a silent message etched in light from the environment. Where there are no lakes, mirages can create the appearance of entire ones. Both highway truckers and desert visitors may catch a glimpse of shimmering pools of water on the horizon on scorching summer days. The water disappears as you get closer. A mirage. Light is bent upward by hot air layers close to the earth, creating this appearance. Light from the sky curves rather than reaches your eyes directly, giving the impression that water is reflecting above. When ancient travelers followed these optical tricks, they found more sand rather than relief because they can be so persuasive. Mirages can still fool the eye into perceiving far-off lakes, floating ships, or distorted roads. They serve as a reminder that the playful bending of light by the atmosphere is sometimes what we see instead of reality. Mirages are weather's illusions in their brief glimmer, fusing art and physics to create sights that vanish as fast as they arise. Ships may appear to float in the sky due to superior mirages. Another type of mirage can occur over icy oceans and in polar locations. A superior mirage was still referred to by one stranger. It occurs when light is bent downward by layers of warm and cold air, giving the impression that distant objects are taller than they actually are. Beyond the horizon, ships can appear to float in mid-air. Coastlines may seem extended or doubled, and castles may loom over the waves. In the past, sailors would tell tales of spectral fleets with masts that rose into the sky and hovered over the ocean. Shapes so bizarre that they sparked phantom land beliefs can be produced by this bending of light. The effect is just as mystical even when the explanation is scientific. A superior mirage serves as a reminder that our perception is continuously shaped by the atmosphere. It has the power to elevate the commonplace to the exceptional. A ship that travels across the sky rather than on water. For a few seconds at sunset, the green flasher is visible. Some spectators catch a glimpse of the green flash, a brief emerald shimmer that appears just as the sun sets. The atmosphere bends light into its spectrum, causing this uncommon occurrence. Violet and blue fade. Green stays just long enough to flare before the sun sets, while red goes right through. It just lasts a few seconds, so you have to pay close attention to catch it. Usually where the horizon is clear, over the water. Poets and mariners interpreted it as a sign of mystery or good fortune for centuries. Its awe is not diminished by the fact that scientists now recognize it as optics. A green flash is a last burst of color concealed in the fading of the sunset, revealing a secret of the sky. Few people have witnessed it firsthand, but those who have never forget the startling green flames. During a full moon, moons have a faint brightness. Although rainbows are frequently seen following storms, the same effect can happen on a much smaller scale during full moon illumination. Moonlight bending through showers at night creates arcs of pale light known as moonbows or lunar rainbows. Moons typically appear white to the unaided eye, their colors too faint for human eyes to discern because moonlight is so much dimmer than sunshine. However, their soft spectrum is exposed by long exposure photography. It is uncommon to witness a moonbow. With a dazzling full moon low on one side of the sky and rain on the other, the conditions must be ideal. Moons were regarded as enchanted nighttime bridges in legend. They continue to be some of the most fragile meteorological phenomena, a faint rainbow echo that seems more like a dream than the real world, a rainbow created by the moon's silvery shine rather than the sun. More than a dozen lightning strikes can occur in the same location. Contrary to the popular belief that lightning never strikes the same spot twice, this is not the case. Tall, conductive things are frequently the items that lightning returns to. There are roughly 25 strikes on New York's Empire State Building annually. A single storm can repeatedly strike mountaintops, television towers, and even a single tree in an open field. These items serve as conduits, facilitating the electrical charge's ascent from the sky to the earth. Random chaos is not what lightning is. It looks for the simplest path while adhering to the laws of physics. This information aids engineers in creating lightning rods that safely draw strikes to safeguard buildings. Therefore, despite its apparent unpredictability, lightning is also oddly devoted, frequently returning to the same locations and leaving its burning mark there. Inside airplanes, ball lightning has been observed to glow. Ball lightning, which are luminous orbs of light that occasionally occur during thunderstorms, is one of the most peculiar and enigmatic weather phenomena. They are described by witnesses as orbs that light white, yellow, or even blue and range in diameter from a few centimeters to many meters. They frequently disappear with a hiss or a bang after drifting slowly, occasionally hovering, and occasionally darting erratically. In the 1960s, passengers on a flight reported seeing a ball of light go down the aisle before vanishing, which is one of the most startling accounts. Whether ball lightning is made of burning vapor, plasma, or something else entirely is still a mystery to scientists. Many scientists initially questioned its existence because it is so uncommon. However, the actuality of it is confirmed by far too many pilot, sailor, and stormwatcher tales. One of the great mysteries of the atmosphere is still all lightning. For a moment, a ghostly fire wandered before vanishing into the storm. In the sky above thunderclouds, sprites flare crimson. The majority of lightning flashes between storm clouds and the earth, striking downward. But occasionally odd transient lights can be seen well above the thunderheads. Sprites. These are enormous reddish light bursts that resemble ghostly jellyfish and extend into the upper atmosphere. They happen when powerful lightning strikes disrupt the electric field in the air, causing energy to be sent upward rather than downward. Sprites are merely milliseconds long, but they can reach tens of miles in height. So swift that they are frequently invisible to the unaided eye. They can occasionally be seen dancing above far-off storms by pilots cruising at high altitude, and their uncanny beauty has been captured on contemporary cameras. Sprites serve as a reminder that storms do not only occur in clouds. They paint the thin air with strokes of flaming red as they stretch upward into the edge of space. Realizing how alive the sky is means imagining a thunderstorm that glows both above and below. Lightning is shot into space by blue jets. Their cousins, known as blue jets, flash in the other direction, rising from thunderclouds into the stratosphere while sprites glow red. They resemble slender cones of blue light that are piercing space. Astronauts on the International Space Station have seen jets up close, describing bright spears rising from storms below, despite the fact that they are uncommon and challenging to study. According to scientists, they are created when electrical charges accumulate at cloud summits and dissipate into the thin upper atmosphere. Blue jets are lightning that escapes aloft, as opposed to regular lightning, which strikes the Earth. They demonstrate that storms are a component of a wider atmospheric circuit that extends from the Earth's surface to the sky, rather than being isolated occurrences. To imagine lightning aiming for the heavens instead of the ground is to catch a peek of the electrical pathways concealed in the uppermost layers of our atmosphere. Electric firestorms can be unleashed by volcanoes. The Earth itself appears to roar during a volcanic explosion, spewing smoke, ash and lava into the sky. However, something equally weirder occurs within these ash clouds, lightning from volcanoes. Similar to ice crystals in thunderstorms, ash particles create static charges as they brush and clash. Then, within the black plume, lightning bolts sprang forth, sparking across the night sky. The intensity of these volcanic storms can be so great that entire heavens are illuminated by electric fire, casting a spooky radiance over the countryside. Witnesses describe the scene as apocalyptic, with the heavens tearing with light above and the mountains spouting flame below. To learn more about how lightning forms, scientists investigate these storms. Those who witness it firsthand, however, experience wonder without the need for an explanation. The double storm of nature is volcanic lightning. Electricity and fire came together, a reminder that the weather on Earth is just as harsh below as it is above. On Earth, there was the strongest storm ever recorded. Even if there are massive tempests on other worlds, Earth has experienced storms with incredible power. Typhoon Tip in 1979 holds the record for being the most powerful tropical cyclone. It was approximately half the width of the United States at its height, measuring more than 300 meters across. As evidence of its tremendous power, its central pressure dropped lower than that of any other storm ever recorded. While severe rains swamped entire districts, winds howled at above 190 meters. The Western Pacific was covered by a huge pinwheel that looked like a perfect spiral from satellites. Despite its eventual weakening prior to impact, its magnitude and power are still unparalleled. It is humbling to think about a single storm that may cover entire continents. The sky still has the power to summon storms of a size that is simply unthinkable, even here on Earth, where we believe we have a good understanding of the atmosphere. For eons without end, Jupiter's massive red spot has raged. The Great Red Spot, a huge oval that swirls in Jupiter's southern hemisphere, can be seen if you look at it through a telescope. This is a massive cyclone that is wider than the Earth, not just any storm, spinning for a minimum of 300 years, and perhaps much more. Ammonia clouds are churned into crimson and beige bands by its winds, which can exceed 400 meters. Fueled by Jupiter's massive atmosphere and energy, the red spot persists for days or weeks, unlike hurricanes on Earth. Over time, it has seen small shrinkage and color changes, but it still spins as a representation of the wrath of the planet. Like a living thing, astronomers follow this storm that has endured for eons. One might sense the scope of time and weather beyond our globe by considering a storm that started before telescopes were widely used and continues to rage now. The hexagonal storm on Saturn revolves precisely around its pole. One of the most peculiar weather patterns in the solar system is concealed by Saturn, a massive storm with 6 sides around its north pole. The size of this hexagon exceeds that of Earth. A precise geometric shape was frozen into a swirling jet stream. It has continued to spin like a cosmic kaleidoscope for decades after being first detected by the Voyager spacecraft in the 1980s. Scientists think that the storm's strange polygon is shaped by standing waves in the atmosphere caused by variations in wind speed. The hexagon appears unreal from above, as if it were created by a cosmic artist rather than by nature. While the hexagon itself rotates smoothly, smaller storms rage within it. There is no storm like this on any other planet. The hexagon-shaped planet Saturn serves as a reminder that weather is not always chaotic and amorphous. It can occasionally create surprisingly beautiful patterns that bring order to the never-ending chaos of planetary skies. The winds on Uranus are quicker than the speed of sound on Earth. In the outer solar system, distant Uranus can seem serene, a sphere of light blue and green. However, some of the fastest winds ever measured are hidden beneath its serene exterior. Jet streams can reach 1,200 mph, which is faster than the speed of sound on Earth as they travel around the planet. These winds create faint cloud bands that are hardly perceptible through telescopes as they whip through an atmosphere of hydrogen, helium, and methane. Why Uranus spins its scales so fiercely is still a mystery to scientists. Its enigmatic weather is influenced by its far orbit, peculiar interior, and tilted axis. All we can see from Earth is a calm disk. Uranus, meanwhile, is anything but serene up close. We are reminded that appearances can be deceiving by this realm of supersonic winds, where storms silently rage across a frozen giant. Even a planet with a calm appearance can roar. Supersonic hurricanes make up Neptune's dark storms. Some of the most severe weather in the solar system can be found on Neptune, the planet that is furthest from the Sun. Images of a huge dark storm resembling Jupiter's Great Red Spot whirling across its surface were taken by the Voyager 2 probe in 1989. These massive hurricanes, referred to as the Great Dark Spots, have the fastest recorded winds on any planet, exceeding 1,300 mph. They can persist for years and cover thousands of miles before vanishing and resurfacing in other places. These storms have a dark, gloomy aspect due to the planet's frigid, methane-rich atmosphere. Even in the faint sunlight at the solar system's border, Neptune's storms show themselves as dynamic moving systems that are fiercely alive despite their distance. Standing there in gusts quicker than bullets is like catching a glimpse of the most extreme, strange, and untamed weather. Glass may rain sideways from some exoplanets. Some of the thousands of exoplanets that have been found are beyond comprehension. Astronomers think that silicate particles, which are microscopic grains of glass, are present in the skies of one far-off planet. These fragments might be flung sideways across the atmosphere by the planet's roaring winds, which reach speeds of nearly 4,000 mph. The end effect is a storm that is unlike any other storm on Earth. Glass rain traveling at supersonic speed in a horizontal direction. The data points to a stunning yet deadly environment with blue clouds reflecting a brilliant hue, as seen by the fading of sunlight as the planet passes its star. You can see how foreign weather might appear when you imagine a location where the rain wounds rather than nurtures. The strongest storms on Earth seem mild in comparison to this. Exoplanets serve as a reminder that the weather we experience is only one example of the many possible outcomes that are shown in the skies of other worlds. Others might have molten iron clouds. Think about the planets that are hot enough to evaporate metals if glass rain seems unnatural. Temperatures rise above 2,000 degrees on worlds that orbit perilously near their stars. In some locations, clouds may form from evaporated metals like iron rather than water vapor. This iron condenses and descends like metallic rain when circumstances change. Imagine being in a storm where molten iron drops hit the ground and sizzle, briefly shimmering before solidifying into metal. Even though they are uninhabitable, these settings challenge our conception of what weather is capable of. Every new finding expands our perspective on what is conceivable by showing that the well-known cycle of rain and evaporation on Earth is but one manifestation of a universal pattern. Strange and brilliant, yet originating from the same physics that regulate our soft clouds, weather on far-off worlds expresses itself in the language of fire and metal. After Earth was born, its atmosphere used to shine orange. The early heavens of Earth were not the same shade of blue as they are now, billions of years ago. Carbon dioxide, methane, ammonia, nitrogen, and gases from volcanic eruptions filled the atmosphere of the infant planet. Without oxygen, the surface was obscured by a faint foreign light as the air shone a hazy orange under the pale sun. Under this peculiar sky, the first forms of life appeared as the waters bubbled with chemical reactions. The atmosphere gradually changed as a result of the release of oxygen by photosynthetic microorganisms. The ozone layer developed, protecting life from dangerous radiation. The haze dissipated, and the sky turned blue. A glimpse of a planet in transition is what it is to picture Earth under an orange sky. A planet without trees, fish-filled seas, or clouds as we know it. The current state of our atmosphere was not always the case. It now tells the tale of life itself and has undergone a significant transformation. Tiny samples of ancient air are preserved in ancient ice. Air bubbles are trapped for tens of thousands of years deep within glaciers and ice sheets. Drilling ice cores from Greenland or Antarctica allows scientists to get time capsules in addition to frozen water. The atmosphere of the year when each layer of ice formed is recorded in that layer. The air that our ancestors inhaled, unaltered for thousands of years, is contained within those bubbles. Scientists may reconstruct Earth's climatic history by examining these ancient samples, which show changes in carbon dioxide, oxygen, and methane spanning hundreds of thousands of years. These records demonstrate the tight relationship between weather and climate and life by revealing cycles of warming and ice ages. Holding a piece of old ice is like holding the breath of Earth from a long time ago, a hint of ancient heavens preserved in crystal, ready to narrate the tale of bygone eras. Weather and the carbon cycle are closely related. The carbon cycle, the continuous flow of carbon through the air, land, ocean, and life, is connected to every breath we take, every storm that occurs, and every wind gust. Carbon dioxide is taken up by plants from the atmosphere and stored in their leaves and wood. Animals consume, exhale, and then give it back. Large volumes of carbon are absorbed by the oceans and stored in deep seas, sediments, and shells. It is released by volcanic eruptions and gradually reintroduced by weathering rocks. This cycle is driven and conveyed by the weather. Carbon is washed into rivers by rain. It is stirred into the sea by storms. The amount of air that plants take in is also influenced by seasonal breezes. Earth's climate and temperature are influenced by the carbon balance. Realizing that weather is more than just the mood of the day is necessary to grasp the cycle. It is a component of the planet's own lifeblood. The globe is both warmed and cooled by clouds. Among the most recognizable aspects of the sky are clouds. However, they have tremendous control over the climate of Earth. During the day, they chill the surface below by reflecting sunlight back into space. At night, they act as a blanket, trapping heat and preventing it from escaping. Whether clouds warm or cool an area depends on how these two effects are balanced. Additionally, researchers are still figuring out which impact is most prevalent worldwide. The functions of various cloud forms vary. While high, thin cirrus clouds are better at trapping heat, bright, low clouds have a tendency to cool. Earth would be significantly colder at night and much hotter during the day if there were no clouds. They control the weather, influencing the sky's immediate mood as well as the climate's long-term equilibrium. Every floating cloud contains more than just vapor. It is a gently moving shield over our environment and a protector of temperature. Ocean and wind patterns are altered by melting sea ice. Sea ice creates a dazzling cover in the Arctic that reflects sunlight back into space. Darker ocean water becomes visible when the temperature warms and ice melts, absorbing more heat. Outwardly, this shift modifies winds, currents, and even far-off weather patterns. The atmosphere changes when there is less ice, perhaps forcing frigid Arctic air further south during the winter or altering rainfall patterns in other places. In addition to upsetting ecosystems, the melting has an impact on creatures that rely on ice for survival, such as seals and polar bears. Frozen water is not all that sea ice is. It is an essential component of the climate engine on Earth. Its yearly cycle of development and melting contributes to the movement of water and air. When it retreats, the entire system's motion is altered, much like when a gear in the planet's machinery slows down. Even far from the poles, the weather has an impact everywhere. Extreme weather is becoming increasingly frequent due to climate change. Scientists around the world are noticing a pattern. The frequency and severity of extreme weather occurrences are increasing. Hurricanes get stronger, floods hit harder, heat waves last longer, and flames spread farther. The Earth's atmosphere is warming, which increases the likelihood of several events. Hotter oceans fueled tropical storms, but warmer air retains more moisture, causing heavier rains. These are not only theoretical developments, they have an impact on everyday life, agriculture, safety, and health. However, they also draw attention to how weather and climate are intertwined. Decisions we make on the ground have an impact on what occurs in the atmosphere. Being aware of this link enables us to mitigate, adjust, and prepare. Severe weather is not solely a product of nature. Human impact is shaping it more and more. Today's floods, droughts, and storms are all part of a larger story that we all contribute to. Sea levels are rising along with storm waves. One of the most deadly aspects of a hurricane or typhoon is not the wind, but rather the wall of ocean water that the storm pushes ashore. Homes are washed away, and coastal cities are inundated by these surges, which can climb several meters. Storm surges start from a higher baseline when sea levels rise due to climate change, which increases their devastating power. Flooding may now occur more frequently in places that formerly only occasionally experienced it. From above, a storm surge erases coastlines by appearing to be the water itself advancing against the land. One of the most obvious reminders of the relationship between weather and climate for those who live close to the water. The surge is more than a simple wave. It is the power of the atmosphere converted into the language of the water, slamming with irresistible force against the shores of humanity. The duration and intensity of heat waves are increasing. Although heat has always been an element of the weather cycle, heat waves have been worse in recent decades. Records are being broken across continents, not by a degree or two, but by previously unthinkable margins. Normally cooling nights continue to be oppressively hot, trapping heat in urban areas. People's desire for coolness causes reservoirs to decline, crops to wither in fields, and electricity systems to strain. More people are killed by heat waves globally than by any other type of extreme weather. Their impact is subtle, yet deadly. Scientists attribute their increasing severity to climate change, which raises baselines and increases the likelihood of extreme events. Heat waves serve as a reminder that weather is more than just dramatic rain or thunder for those who experience them. The air is still stifling at times, a constant warmth that permeates every nook and cranny, and summers all around the world are increasingly defined by these heat waves. Rainfall patterns around the world are changing. Life on Earth is defined by the cycle of rainfall. Rivers, forests, and agriculture are maintained by monsoons, seasonal storms, and consistent rainfall. However, these trends are changing as the climate changes. While some areas are experiencing prolonged droughts, others are experiencing greater rainfall. Once fruitful areas turn drier, dry zones widen, and storm paths drift. Communities that rely on consistent rainfall face uncertainty and hardship as a result of these shifts. These days, satellites monitor rainfall all across the world, revealing how moisture belts are shifting and changing entire regions. The globe appears to be redrawing its wet and dry map. Where and when they unleash their bounty is changing, but the air still contains water and clouds continue to form. One of the subtle changes in weather is the worldwide reorganization of rainfall, which also affects the growth of deserts, the movement of rivers, and the equilibrium of life itself. As the environment warms, there may be more lightning strikes. Heat and moisture are the main causes of thunderstorms. Additionally, both chemicals are more plentiful as the planet heats. According to some research, this may result in lightning strikes occurring more frequently in the ensuing decades. Wildfires, ozone production in the atmosphere, and risks to humans and animals all increase with lightning. Satellites already map the changing patterns of millions of lightning bolts annually. The connection between warming and lightning serves as a striking reminder of how even slight variations in temperature can have a significant impact on storm activity, even when forecasts are complicated. Every lightning strike is an unexpected outburst of energy generated by the restless turbulence of the atmosphere. The storm's sparks may multiply as the Earth gets hotter, bringing more of nature's electric fire to the skies. The skies may burn more frequently than ever in the stormy future. Future hurricanes are predicted to get more powerful. Hurricanes get additional fuel from the heat that is stored in the ocean as it warms. What used to be a modest storm can now become a monster. Its surge is rising higher against the coast, its winds are speeding up, and its showers are getting heavier. This trend is already recognized by scientists. Fewer but more powerful storms that frequently make it to classifications 4 and 5. From above, satellites record their enormous and captivating spirals. On the ground, people encounter waters that rise like walls and winds that resemble jet engines. These storms of the future will be tales of preparedness, adaptability, and resiliency in addition to being natural occurrences. It is both depressing and encouraging to think of stronger hurricanes in the future. As the atmosphere reflects the warmth we contribute to the Earth, it becomes more acute. They serve as a constant reminder that the weather is dynamic, restless, and poised to unleash its full power. Droughts and floods can occur more frequently. People are starting to sense a new beat all around the world. Extended periods of dryness are interspersed by unexpected downpours. The warmer atmosphere, which has the capacity to hold more water vapor, is linked to this alternating pattern. Storms quickly dump more water, overflowing rivers and soils, while dry spells make the area more arid. During the same season, crops may experience both thirst and drowning. Landscapes can be altered by these oscillations between extremes, which can leave behind fractured deserts and new river courses. The atmosphere is tugging harder on both ends of its spectrum when such disparity is observed. The weather cycle has always included both droughts and floods. However, they are becoming more frequent and frequently show up in the same areas during the same years. The sky itself seems unable to make a decision, providing nothing at one moment and then everything at another. An unseen fleet of satellites discreetly hovers high above Earth, monitoring the atmosphere, and the satellites now cover the entire planet. They monitor temperature, scan moisture, follow cloud movements, and even look into the center of storms. They transmit streams of data back to Earth every few minutes, where forecasters use it. No part of the world is hidden from these observant eyes. Sandstorms sweeping over deserts, hurricanes churning over oceans, or even the subtly rising water vapor before a storm occurs. These satellites have revolutionized forecasting, saving countless lives by enabling us to foresee tragedies days in advance. However, they also offer aesthetics. Pictures depict the weather on Earth as glistening, moving, multicolored mosaics. We have come a long way in our ability to read the language of the sky when we discover that robots are always watching over us, transforming the chaos of the atmosphere into patterns that we can study. Storms can be modeled by supercomputers days before they occur. Supercomputers hum like enormous brains, performing billions of calculations every second inside enormous halls that are cooled by fans. With this ability, scientists may create weather simulations by feeding in satellite data and viewing atmospheric conditions and surface temperatures. These models can anticipate the trajectories, strength, and rainfall of hurricanes by spinning them up in virtual oceans days before they really develop. With the atmosphere rehearsing its potential moves, each run of the model is like a rehearsal of the future. Despite their flaws, these simulations are incredibly effective at providing communities with advance warning of storms or heat waves that used to occur without warning. Using mathematics today to see the weather of tomorrow is a form of time travel. Science has learned to dream with the sky, and it is amazing to imagine that unseen equations that are calculated at breakneck speed may whisper to us what the clouds, winds, and showers will decide in the near future. Today's forecasts are more accurate than ever before. Forecasting the weather was essentially a guessing game not long ago. Townspeople relied on the feel of the air, farmers on proverbs, and sailors on the color of the sky. Today, however, forecasts are remarkably accurate. We can forecast rainfall to the hour, follow storms across oceans, and even warn of tornadoes minutes before they arrive. Today, physics, satellites, and models that process billions of data points underpin what originally appeared to be fortune-telling. Even though we still gripe when rain spoils a picnic, it's important to acknowledge how amazing it is that we can predict the atmosphere's mood days in advance. Humanity's collaboration with the sky is forecasting. Yes, it is imperfect, but it is far more accurate than it has ever been. They demonstrate the extent of our current and potential future understanding of weather. However, weather is unpredictable due to its chaotic nature. The weather continues to be a master of surprise for all of our models, satellites, and supercomputers. Being a chaotic system, the atmosphere is extremely sensitive to even the slightest changes. Storm paths, rainfall patterns, and cloud scattering can all be abruptly changed by a change in wind, a patch of warm sea, or an abrupt convectional surge. Long-term forecasting is challenging because of this vulnerability. After a week or two, the atmosphere becomes unpredictable due to the multiplicity of innumerable small factors. The butterfly effect is another name for it. The notion that the weather can change with the slightest flutter. This unpredictability is a natural occurrence rather than a defect. There are secrets in the sky that we might never fully unravel. Knowing this means accepting weather as a wonder as much as a science, a reminder that certain earthly rhythms will never reveal their secrets. Animals are frequently able to detect storms before people do. Animals hear the sky in ways humans hardly comprehend long before meteorology. Sensing changes in pressure or the faint rumbles of distant thunder, birds may take flight before a storm comes. While dogs and cats hide, cows and horses can become restless when the air gets heavy. They have ears that can detect sounds that we cannot. Ants closing their tunnels before rain and bees returning to their hives are examples of how even insects can respond. According to measurements, many animals are significantly more sensitive to variations in barometric pressure than humans are. Farmers used to rely on these small clues, keeping an eye on herds and flocks to see what the sky was getting ready for. Even though satellites now monitor the atmosphere, animals are still the earliest weather forecasters because they are sensitive, instinctive, and able to pick up on meteorological hints. Their knowledge serves as a reminder that forecasting is not just a high-tech endeavor, but is also intricately interwoven with daily life. A drop in pressure might cause pain in your joints. A lot of people have hand, shoulder, or knee pain right before a storm. There is no deception here. Body tissues can be impacted by variations in barometric pressure, which is the weight of the air pressing down on us. Joint fluids may gradually move as pressure drops before a storm, aggravating irritated areas and sensitive nerves. This may cause stiffness or aches that seem to be a predetermined outcome for those with arthritis. Despite the fact that not everyone is sensitive, enough people are affected that medical professionals take it seriously. It appears that changes in the unseen atmosphere are detected by the human body, which functions as another type of weather station. It's amazing to consider that our bodies are affected by the same pressure shifts that propel clouds and winds. Sometimes our bones recall first, aching from the echo of impending storms as the sky gets ready to rain. Before a tornado forms, the sky may turn green. The sky can occasionally glow a spooky green just before powerful thunderstorms release their power. This eerie color is produced when sunlight scatters light in a way that intensifies green wavelengths as it passes through tall storm clouds that are laden with rain and hail. For meteorologists, it may indicate that a storm is powerful enough to produce tornadoes and hail. The green sky appears unearthly to those who see it, like a veil of color stretched beyond the horizon. It's a frightening quiet before chaos, according to storm chasers. The environment glowed with a warning of its own peril. The location is just as eerie even when the science underlying it is known. The warning sign for weather is a green sky. It serves as a bizarre reminder that something strong is simmering just above the clouds, waiting to unleash its abrupt wrath on Earth. Earth's weather is its lifeblood, never stationary, always moving. Weather is always changing beneath the blue dome of our sky. Clouds form and dissipate, and winds turn. It rains, and the sun comes out once more. Every wind, drop, and glint of light is a part of a living system that is always renewing and restless. Observing the sky is like feeling the Earth's heartbeat. Always there, sometimes sweet, sometimes wild. Our lives are not merely framed by the weather. Fields, forests, and oceans are all supported by this rhythm. It is the energy that whispers through the silent drift of snow, creates civilizations, and recounts tales in rainbows. It is not a metaphor to refer to it as Earth's heartbeat. Our world is alive because of the movement of energy and the pulse of the air and water. We are constantly passengers under its ever-changing song, even though we are able to measure, forecast, and model. Thus, our voyage across the boundless sky comes to an end. We have traveled through raindrops molded by invisible forces, clouds as heavy as mountains, and storms and sunshine. We have been across deserts where rain never falls, up into the weird brilliance of sundogs and fairies, and into the cold heart of glaciers. As a team, we have demonstrated that the weather is more than just the setting for our days. It is a dynamic rhythm that shapes history, life, and the Earth. Weather is both old and modern. Long before satellites, it brought down empires. Even with all of our computers and predictions, it still surprises us. It roars in the voice of hurricanes, sparkles in the glimmer of rainbows, and whispers through the wings of butterflies. It is both disorder and order, peril and beauty, a reminder that life is alive both above and below our heads. You might be able to visualize the sky outside your window, gradually changing in its own peaceful manner as you lie here right now. Perhaps a light cloud moves across the moon, or a breeze rustles the leaves. The atmosphere is never at rest, even in this silence. Carrying the seeds of tomorrow's storms and the serenity of tomorrow's dawn, it is the planet's enormous breath that circles indefinitely. Allow the thought of the weather to soothe you as you fall asleep. Its cycles serve as a reminder that everything changes naturally, that calm always follows a storm, and that nothing ever remains the same. Above you tonight, the same skies that were once orange when Earth was a baby now shine steadily, eternally, and with awe. I appreciate you traveling with me. I encourage you to subscribe and come back if you have liked this peaceful exploration. You have a lot more science and tale nights ahead of you. Let the winds rest for the time being, though. Allow your thoughts to lighten and the clouds to dissipate. Rest in the silence of the Earth's heartbeat, in the rhythm of the sky, and in the peaceful understanding that you are a part of this enormous, dynamic tale. I hope your dreams float on a light wind like clouds. Good night.